Hi there, thank you for your interest in our work on creating animations for basic science research. Now, why make animations, you might ask? Let me give you an example. Some of you may have attended or will attend Dr. Dudna's plenary talk on the CRISPR-Cas gene editing tool. This protein that I'll show you in a second is this pink structure here, and it has this magical ability to recognize sequences of DNA, cut it out, and insert a new one in its place. Now, that is a very simplified explanation of what is actually happening. Now, imagine watching an animation on how CRISPR-Cas works. You might first see smaller proteins assembling together to form the CRISPR-Cas complex. Then you might see this mega molecule stray into the nucleus, and when it finds the right strand of DNA to cling on, it holds on tightly and then goes snip. Isn't this visual much more engaging? At Texas A&M College of Engineering, we use animations to bridge the gap between our scientists and a science-curious audience. And animations help us achieve this goal in many ways. For example, we use animations sometimes to describe a scientific process, a scientific concept that a lay person might find hard to visualize. Let me give you a few examples. So we used an animation to describe a new self-healing material that has cross-linking molecules. These cross-linking molecules after attack can snap back into place, hence restoring the material. I'll give you another example of another scientific concept that we animated called a defect. Now, unlike the tear that I showed you earlier, a defect is much more subtle, where the atoms rearrange themselves around a natural fault line within the material called here as the coherent twin boundary defect. Sometimes we might use animations to reiterate a central idea within the scientific discovery. For example, our researchers once described a study where they used tiny yet perceptible buzzes of currents to give surgeons an accurate perception of distance to contact. This is particularly useful to them, the researchers said, during telerobotic surgery. Now, in order to illustrate that, we created this animation, and I'll show you a part of it. Here, you can see flashes of current that increase in frequency, and this would indicate that the distance to contact is very small. And on the other hand, you can see flashes decreasing in frequency to indicate a safe distance from an underlying structure. Lastly, we've also used animations to give an additional or an alternate perspective to a scientific discovery. This is sometimes very important for basic science research when the overall broad implication of the research is not very apparent. Let me give you another example of this. Our researchers discovered, or designed rather, a new material that had brain-like properties. We weren't sure whether the broad audience would be aware of having such materials. Do we need materials that behave like the brain? In other words, can the brain do something that silicon chips can't? The answer is yes, pattern recognition. To give an example, we thought of the cocktail party problem. The brain has absolutely no trouble recognizing, say, the sound of a friend in a din of chatter, but this simple task for most sophisticated computers is extremely hard. To illustrate the cocktail party problem, we chose to draw a line drawing of the brain, and we showed the different people at the party as an array of dots. When a friend makes a sound, sound waves from the dot expand, and it reaches the brain, and then bingo, the brain recognizes it's a friend and turns itself to the blue dot. The advantage of using this real-world relatable example is that we could then create more illustrations and animations to build on this concept and show more complex properties of this material. If you'd like to see how we created this animation, please check out our storyboard on the poster. If you'd like to see the complete animation, click on the QR code next to the storyboard. I'd like to end by saying that animations creating animations is a very collaborative process that involves the expertise of the scientists, science writers, graphic and sound designers, where each one brings something to the table. In our poster, we have some information of how an animation team might look like in a university setting, some guidance on how to create scripts for animations, and a storyboard from one of our own animations. We've also included a resource document called the Science Animation Primer that can guide you through the steps of creating animations in your own institution. We hope that our poster will pique your interest and you would consider using animations as one of your science communication tools to tell compelling stories on basic research. Thank you for your time, and we hope to answer some questions.